Hello YouTube, this is Prashant. Welcome to my channel. In this video, we're going to be discussing two questions on redox reactions. This time though, it is going to be involving equivalent weight and how it's going to be helpful in solving questions and what to understand over that. Alright, so the first question which we're going to be looking at for now is going to be involving equivalent mass, of a bivalent metal which is given as 32.7. Molecular mass of its chloride is going to be how much? This is of course a typical JEE mains type question. It of course can show up in a JEE advanced exam also, but not anytime soon, because it probably would have shown up a long time back. The level of the JEE advanced exam has definitely increased. If this shows up in a JEE mains paper, it would be a reasonably easy to moderate level question. So let's have a look at this question. The equivalent mass of a bivalent metal. The moment they say it's a bivalent metal, that means the metal should be something which will basically be having a charge of +2. Meaning the molecular mass, or rather in this case atomic mass of the metal, will effectively be what? Equivalent weight into 2. So the equivalent weight multiplied by 2 is actually going to be the atomic mass of the metal over here. And when you're going to be considering the metal chloride formula, it will of course have a formula of MCl2. Why will it have a formula of MCl2? Simply because chlorine is always going to be present in the form of chloride with a metal, and in the chloride ion, chlorine is going to be having -1 oxidation state over there. Alright, so when you're going to be having atomic mass of the metal M being equivalent weight of the metal M multiplied by 2 over here, what is the value going to be? Well, metal M is going to be given equivalent weight as 32.7. So it's going to be 32.7 multiplied by 2, meaning we are going to be having it as 32.7, meaning it's going to be 64 plus 1.4. So 64 plus 1.4 means it is 65.4. So you're going to be having 65.4 being the weight of that particular metal's atom in this case here. So we can say atomic weight of the metal M in this case is going to be 65.4 in this scenario over here. Alright, so if the atomic weight for the metal is 65.4, the formula is known as MCl2. So what should be the molecular mass of its chloride? That is what is asked over here. So when you're going to be looking at the molecular mass of the chloride in this particular case here of the particular compound, it is going to be MCl2 formula wise, right? So if I have to add the values up, what do I have now? Each chlorine atom is going to be having mass as, what is the value? 35.5, correct? So when you're going to be having this particular MCl2 considered over here, Cl2 will of course have 71 as the mass in this particular case here, meaning the MCl2 will have molecular mass being 71 plus 65.4, which of course is going to be, the only option with a 0.4 in this particular thing is going to be 136.4. So the student who basically had asked me this question has gotten this particular question, or at least the student has marked it correctly in this case here. So as I said, this is a typical JEE mains easy level question, not a difficult question. If it shows up in a JEE mains paper, you can think of it as a relatively easy level question in the JEE mains setting. Okay, I did promise you two questions, so let's get to the next question. So the next question is going to be involving equivalent weight again, redox reactions of course. Equivalent weight of MnO4 minus in acidic, basic and neutral medium is in the ratio what? So we need to know a little bit information about how MnO4 minus behaves in acidic, basic and neutral medium. Now, one key thing which they have not mentioned in the question over here is MnO4 minus behaves as an oxidizing agent. It cannot undergo any further oxidation because manganese is already in the +7 oxidation state in MnO4 minus. This is the highest possible oxidation state for manganese. Alright, so it is already in the fully oxidized state. From here, the MnO4 minus can only undergo reduction. It cannot undergo any further oxidation, which is why it only behaves as an oxidizing agent and undergoes reduction. Or you can say it gets reduced. That's a better term to use over here, so I'll use that. So it gets reduced in the reactions. Now, depending on the medium, the permanganate. Now, MnO4 minus has a very standard name. It is called as permanganate ion. So this particular permanganate ion is going to be something which can be considered as a pink or purple solution. Alright, so this MnO4 minus is going to be a pink or a purple solution over here. That pink or purple solution undergoes different types of reactions depending on which medium it is present in. So when I'm going to be considering the medium this particular fellow is going to be actually present in. Let me just get to the page again properly. So when I'm going to be considering the medium it is present in and the type of reaction it actually shows, let's quickly try to understand what are the different styles of reactions the MnO4 minus performs according to the medium. Now, this particular permanganate, when it is present and it is performing a redox reaction, if you are doing it as a redox titration, you don't need another indicator actually. The permanganate acts like a self-indicator. So when I say self-indicator, what do I really mean? Let me just have a sip of water. Throat was a little parched. So when the permanganate is going to be behaving as an oxidizing agent in different mediums, it will basically end up giving different products. When it is acting as an oxidizing agent in acidic medium, the final product it will be giving is manganese plus 2. Now, if it is acting as an oxidizing agent in neutral conditions, that is in plain water, it will end up giving the final product as manganese dioxide MnO2. And if it is acting as an oxidizing agent in a strongly basic medium, so OH minus is present in large quantity, of course it will end up giving a different product compared to the other two which you have seen over here. It will be giving me MnO4 minus 2 ion in this particular case here. This MnO4 minus 2 ion is actually called manganate ion. Alright, it is called manganate ion, and there is going to be different colors for each of these here. As I mentioned just a while back, the permanganate ion is going to be considered as a pink colored solution usually. Okay, it of course might also look a little bit purplish depending on how concentrated that particular permanganate is. The Mn2 plus is going to be colorless. The MnO2 is actually formed as a precipitate, which is why I am using the downward arrow mark over here. The downward arrow mark indicates precipitate over here, and it is a black precipitate. Alright, it is a black colored precipitate. It comes out as a black color solid. Lastly, the manganate ion is going to be something which is going to be a completely different color. It is going to be green colored solution in this particular case over here. So we're going to be having three different colors being seen over here for the permanganate when it is acting as an oxidizing agent. What are the three different colors we are going to be seeing? If it is acting in an acidic medium, it will give me colorless. If it is acting in neutral medium and it is undergoing the reaction, it will give me a black precipitate. Actually, though, it is not just neutral medium. I should mention that in a light basic medium, mildly basic medium also, it gives me the actual MnO2 only. It doesn't give me anything else. In a strongly basic medium, it will end up giving me MnO4 minus 2, which is the manganate ion over here. So in each of these cases here, let's get the oxidation numbers out now. Manganese is in +4 here and in +6 here. So the N factor for each of these cases in acidic medium is 5. In the neutral or mildly basic medium, it is going to be +7 to +4, meaning N factor is 3 here. And in the last case, it is +7 to +6, meaning N factor in this case is 1 for this particular case here. Meaning we are going to be having in ratios they are asking over here now. So when they are asking for ratio over here, they are asking acidic to basic to neutral over there. So it is going to be, effectively speaking, 5:1:3. Acidic, then basic, then neutral they are asking. So it is 5:1:3, which means this option C is the correct answer for this particular question over here. I'll see you guys in some other episode. Take care till then. Thank you very much, guys. Bye-bye.